Okay, welcome to Chapter 4, Part 2 of the Aromatic Ingredient and Flavors applications. Okay, so last week we spoke about the natural, the extraction of natural flavors. So for this part, Part 2, we're going to talk about synthetic flavor. Okay, synthetic flavor, how to create the flavor in a synthetic way. Okay, so the conventional flavor using the synthesis methods. So I believe that most of you have actually gone through the organic chemistry and have exposed to these methods in the practical. So basically, this method is using the reactions, the esterification reaction between alcohol and the carboxylic acid. Okay, so after when they undergo esterifications process, then they will form what we call a flavor ester, accompanied by the condensation which generate water. Okay, but the flavor ester is the one that is really the one that give the flavor. Okay, so the flavor ester is a compound formed from the reaction between a carboxylic acid, again a carboxylic acid is a weak acid, and an alcohol in the presence of a strong acid as a catalyst. So the catalyst can be anything, strong acid, like sulfuric acid, hydrochloric acid is one of the very common acid catalysts used in the reaction to generate flavor ester. Okay, so you can see from here, these are some of the common ester used as a flavoring agents. Okay, so you got, for example, the so you have here the ethyl methanoate. Okay, the flavor is the rum flavor. Okay, so this is the molecule, all right, the ester molecule. This is the molecule structure for pentyl ethanoates, which give the pear and banana smell, or flavors. Then you got here octyl ethanoate, which is the orange flavor, and so forth. Okay, so you can see that these are some of the common ester used as a flavoring agent. So you may be wondering, what's the difference? I think I have mentioned in part 1, again, I just repeat again, what's the difference between a natural and synthetic flavor? So through the extraction method from vanilla bean, for Madagascar, for example, so the extraction, they see from here, vanilla extraction from the Madagascar vanilla beans, you will have four components, the four major components after the extractions. The extract contains these four components. Vanillin, about 82%. You got additional molecules, 4-hydroxyl benzaldehyde, 7%, 4-hydroxyl benzoic acid, 3%, vanillic acid, 7%. Okay, so you do notice that these the vanillin is basically the compounds, that is giving the characteristic vanilla flavor. What happened is that these three, you will notice that there is a flavor as well accompanied with the molecule. So for this molecule, which is about 7%, it actually gives bitter almond flavor. This one gives the faint nutty flavor, and vanillic acid gives a creamy flavor. Okay, so these three molecules in the extract will complement together with the vanillin to give you a full flavor, a fuller flavor. All right, so there's a saying that while someone tasting an artificially flavored food will be able to identify the principal flavor, which is vanilla flavor, because of the presence of vanillin, but it may seem bland or taste like something is missing. Something is missing because if you compare with the synthetic vanillin, which is 100% of vanillin, there's a missing of these components, which is roughly about 17%, that give you this additional complements with the vanillin. That's why you feel that something is different, something is missing, and so forth. So this is basically the the difference. Okay, the difference is that the extracts contain additional molecules that give the flavor, okay, or complement with the vanillins to give you a fuller flavor. Okay, whereas synthetic is able to generate 100% of vanillin. Okay, you're still able to identify its vanilla flavor, but something is missing. Okay, so vanillin is 4-hydroxy 3-methanol seal benzyl aldehydes. Okay, so this one is the molecule structure. Okay, so now you understand what's different between the natural extracted flavor compared to synthetic flavor. Natural, more molecule. Synthetic is 100% the character impact flavor. Okay, you may be wondering, is it safe? Okay, it's the same. Okay, vanillin is vanillin. The structure is exactly the same. Okay, so and also the FEMA, okay, FEMA, in the FEMA flavor organization, okay, the which is the flavor is in charge of the flavor. Okay, so basically is in charge of the flavors in the United States. Okay, the FEMA stands for the Flavor and Extract Manufacturer Association of the United States. Okay, FEMA, FEMA. Okay, which is comprised of different stakeholders, including the flavor manufacturers, the flavor user, flavor ingredient supplier, and other with an interest in the US flavor industry. Okay, the FEMA is very strong. They govern. Not govern, they sort of like in charge of the flavor industry. Yeah, okay, so you can see from here, vanillin, okay, which is the one that I showed you just now with the structure. Okay, if it's synthetic, is 100% of this, is listed as GRAS. GRAS means generally regarded as safe. Okay, so the quantity that for usage has been written over here. Okay, you can see that is widely used for different type of the food products, beverage, ice cream, candy, baked goods, okay, gelatin, and so forth. All right. So if you're interested to see the whole list of the FEMA GRAS list, okay, you can refer to the Chapter 4 handout number 8. Okay. You can also go to their website, femaflavor.org, okay, flavor library, and you can search for the flavor molecule. Okay, in this case is vanillin. Okay, so this come to a very interesting topic. All right, nowadays, as you see, a lot of people say that don't use artificial flavor. Okay, use natural. Okay, and the consumer demand more and more natural flavoring. Okay, foodstuff containing artificial and synthetic flavor are mostly avoided because the consumer doubt that these flavor producing components are toxic to their health. Okay, so that's why because of the bad image, you may see that the trend is going more towards the natural flavor. Okay, the only options available is the extraction of the flavor from the food products, okay, from the plant-based, or you can generate from cooking and so forth. So there's another way that is possible to go about synthesizing the food flavors, okay, which is using what we call the biosynthesis. Okay, biosynthesis uses the enzymes to actually generate the food flavor. Okay, it's still considered as synthetic, but it's using enzyme. That's why it's called biosynthesis. And the good news is that using this method to generate the food flavors, okay, is good, is pure. Okay, and another thing is that it is regarded as natural. Okay. Okay, let's look at this biosynthesis of food flavor. Biosynthesis of food flavor is a wide range of flavors can be produced naturally. Okay, the word naturally by biotransformation. Bio means using enzyme and something is in bio. Okay, of chemicals from their precursors using enzymes or whole cells, okay, fermentations, productions of flavors from agricultural waste or plant cell. Okay, later I will give you some examples of these. Yeah, you can actually from the waste, like the almond meals, okay, or almond meals that you generate after you squeeze out the almond milk. Okay, so you can use that to generate the flavor as well. Okay, because these wastes, they contain the precursor required to generate the flavor components. Okay, so biosynthesis provides an abundant amount of compounds with flavor of cherry, almond, strawberry, pineapple, cheese, onions, grapes, and so forth. Okay, they are mainly synthesized using biocatalysts such as lipase, carboxyl esterases, hydrolase, and protease. Okay, they're using enzymes to actually generate the fruit flavors. Okay, the food flavors. Okay, and using this method, as I mentioned, is regarded as natural. Okay, so the benefit, what's the benefit of biosynthesis of flavor? Biosynthesis of flavors are eco-friendly, has specific selectivity, very good. Specific selectivity actually is good here, because it's more pure. Okay, waste can be recycled easily, okay, and can be produced under mild reaction conditions, for example at room temperature. Okay, if you use chemical, okay, like using the one that I mentioned, conventional esterification process, you need to use a catalyst. Okay, you need to use an acid catalyst and at high temperature. Okay, you can actually for this biosynthesis, you can even use at neutral pH, because enzyme usually their activity is highest at neutral pH. Okay, and solvent-free environment compared to a chemical synthesis here. So using all this is much better option, and the end product is much more pure and much more good. Okay, and there's a adoption of this natural produced flavor will be beneficial to human health and create chemical-free atmosphere. Okay, by saying that, you know that there are a lot of benefits. Okay, the one thing is that the cost. Okay, using enzyme, the cost will be higher. But again, alright, is you can generate a lot of the flavor using these methods, and is regarded as natural. So definitely is worth the cost. Okay. Okay, examples. For example, this biosynthesis of almond tasting benzaldehyde. Okay, so the almond tasting benzaldehyde can be produced from cyanogenic glucosides amygdalines. Okay, which is the present in the cherry kernels and almond meals that I mentioned about, using the beta glucosidase. Okay, this is enzyme, and maltodextrinitrate lyase enzymes. Okay, using these two enzymes to generate the benzaldehydes. So amygdalines, okay, which is this molecule, is present in the almond meal. Where is almond meal? Almond meal can be one of the waste product from squeezing out the almond milk. Okay, so you can use that and throw in the enzymes. Okay, with the presence of enzymes, you will create this molecule. Okay, with this enzyme, you will generate the benzaldehyde. Okay, and this benzaldehyde over here gives the almond tasting flavor. Okay, another one, biosynthesis of L-menthol. L-menthol, okay, make sure that is L-menthol. L-menthol is the flavor components, okay, in the mints, peppermints. Okay, you can what you can do is that you can generate the L-menthol, not the D-menthol, yeah, the L-menthol using the microbial lipase. This microbial lipase preferentially hydrolyze the L-methyl esters into the L-menthols. So you can see from here, if you got these two isomers, it will generate, okay, you will use the microbial lipase will use the L form, okay, to generate a L-methanol. Okay, and the D one will not be touched here. So you can, after that, you can isolate the L-methanol and give you the peppermint flavor. Another one, you actually can use lipase okay, also for esterification purpose. Among different enzymes, lipase is the most widely used for the flavor development. Lipase is used for esterification in organic solvent to produce flavor esters such as the isoamyl acetate, banana flavor, geranyl acetate, the rose flavor, citronella acetate, okay, the lemon flavor. Okay, so you can use these, okay, like essential oil, alcohol, okay, with the weak acid, okay, in combination of these two molecules in the presence of lipase. Okay, of course you need to adjust the concentration of enzyme, the agitation mixing speed, the temperature and the time. If with all these conditions all well, you will produce a esterified product. Okay, so usually the flavorists, okay, they will concentrate in playing with this condition to make sure that the yield is the highest. Yeah, so the esterified product should give you the flavor. Okay, banana flavor, rose flavor, lemon flavors. Okay, all these flavor can be further identified or maybe tested to make sure that the flavor component is there. Okay, using the GC method, the one I talked about in part 1. Yeah. Okay, so last but not least, these are some of the flavor components. Okay, you can see from here the substrates. This is the substrate for reactions. These are the enzymes for that will convert the substrate to the flavor products. Okay, so some of these I have mentioned already. One thing that I want to emphasize is using protease, okay, for generate the flavor. You can see from here the protease actually can create the savory flavor. You can see over here, soy sauce flavor, natto, tempeh, fish sauce, miso, savory flavor, and so forth. Yeah, the savory flavor is one of the you can use the protease to generate the flavors. Yeah, protease means is the enzymes that break down the protein. Okay, so you can use that to generate the savory flavors. Okay, the rest you can see is more or less the sweet flavors. Yeah. Okay, so if you're interested, you can go for more to read more in the chapter 4, handout 4 and handout 7. Okay, so basically the synthesis flavor, conventional, they use the weak acid, the alcohol in the presence of high heat and the acid catalyst to generate the flavor. Because of the negative influence, okay, the negative of the publicity, consumers start to reject that. So now the manufacturer now they concentrate in using the natural way, okay, the natural flavor, natural synthetic flavor. So you can use the biosynthesis, okay, biosynthesis to generate the synthetic flavor rather than using the conventional methods. And this is now much more well received, okay, and is more friendly. Even you can label as natural flavor, okay, because it's using the bio way of generating the flavors. Okay, but one thing, same thing, yeah, same thing, synthetic flavor, very high concentration. Okay, the extraction method, you got some other flavor components. Okay, these some other components from the extracts can give you a more full flavor, but synthetic flavor, okay, is still very pure, very high percentage. Okay, so there's still a difference over there. Okay, so if you want to create a product that you want to feel more, then try to take from the extract. Of course, more expensive. Okay, if you use the synthetic flavor, people still can recognize the flavor. Okay, if you use the biosynthetic flavors, people you can say that it's natural. Okay, because it's created using enzymes. The concentration will be much more higher. Okay, that's fine. But you also can use it to add into the food. All right. So that's it. Okay, for this chapter. Okay, chapter 4, part 2. Okay. Please remember to go to Padlet. Okay, and write down your name. If you got questions, please ask the question. If you got no question, please indicate no question so I can mark the attendance from there. Okay, so thank you very much. Okay, hope you enjoy the session.